Okay, so as in the last video, we have studied the discovery of proton, which was done by Goldstein scientists. In today's video, we are going to discuss about the characteristics or properties of canal rays, or these were also known as positive rays, right? So let me write here. Today we are going to discuss about characteristic or properties of canal or positive rays, right? So our today's topic is the characteristics or the properties of canal or positive rays, right? Initially we are going to identify the charge of proton, right? Charge of the positive rays. So we know that the charge will be identified or determined by the electric field, right? For example, I have this positive ray, right? This is what? This is positive ray, which I have made it pass through the electric field, right? So here I have positive charge and here I have negative charge. When I made this pass through the electric field, this ray got deflected towards negative charge, right? This ray got deflected towards the negative charge. So because of this experiment, we got to know that this ray has positive charge since this was deflecting towards the negative charge. So positive charge is deflected towards negative negative charge in the electric field. Negative charge, right? So let me give here the heading as well. This is the charge determined by the electric field, right? So now we got that the charge on the positive ray is positive since it was deflected towards the negative charge, right? Let's go with another property, which is basically the mass, right? So mass, we know that is determined by the magnetic field. So let me write here. We are going to identify the mass, which is determined by magnetic field, right? For example, I have this positive ray, right? This positive ray. Let me write this here as well. This is positive ray. When I made this pass through the magnetic field, which means here we have, you know what? We have north on the upper side, but I'm making south on the upper side and north on the downside, right? So we know that anything will be having mass will be attracted towards the north, right? So this was attracted towards the north, and we got to know that the thing which has mass will be attracted towards the north, right? So this has proved that this positive ray has mass as well. So let's write this too. This positive ray has mass as well, which was determined by magnetic field, right? Since it got deflected towards north pole, right? This was deflected towards the north pole. That's why we got to know that this particular particle has mass as well, right? So now we are gonna discuss the EM ratio of it, right? EM is basically nothing. It is just mass to charge ratio or charge to mass ratio, right? Wait, let me write here. This would be nothing, but it would be charge to mass ratio, which is E by m, right? E by m. So this is basically nothing. It is charge to mass ratio. And what is the charge to mass ratio of positive rays? It is 9.54 into 10 to the power 7 coulomb per kg, right? So let me write this as well. It would be helpful then. The value is 9.54 into finding multiplication sign, okay, 10 power 7 coulomb per kg, right? Coulomb per kg. Why the unit is coulomb per kg? Since the charge unit is coulomb and the mass unit is kg, so coulomb per kg. So the EM ratio of positive ray is 9.54 into 10 to the power 7 coulomb per kg, right? So this was the mass to charge ratio, charge to mass ratio, right? Now let's talk about how they do move. They do move. Do they move in a straight path or they follow wave path? Let's talk about that, right? For, for instance, this is, I have positive ray, right? And this is the discharge tube. Here I have, the electrodes, which is cathode and anode, right? Anode, positive charge, and this is cathode, negative charge, right? Now we know that the positive charge will be moving from anode to cathode, right? So it will gonna travel in the straight path. They're gonna follow the straight path. They'll move straight, 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 straight. So let's write this point here as well, which is the most important point, right? So these rays, let me highlight this. These rays travel in straight lines, which are basically perpendicular to the anode surface, right? So how they do move? They move in straight path, right? They move in straight path. The the fourth property, which says these rays produce the fluorescence as well, right? And we have discussed that in the discharge tube it is coated with zinc sulfide, right? So they produce fluorescence when they strike with zinc sulfide layer. For example, I have this discharge tube here and this hole is covered with the zinc sulfide. Let's make that with this color, right? So this is basically this is a bit not good. Now is it fine, right? So this is basically zinc sulfide, which is the fluorescent material. Let me write this here. This is nothing but zinc sulfide. So this whole discharge tube is coated with the zinc sulfide, which is the fluorescent material, which is fluorescent material, which will gonna get glow when any particle will strike to the wall of it, right? Now we know that here we have cathode, perforated cathode. So let me write the perforations here too, which means holes. And here we have anode, right? This is anode. And positive rays we know that are moving from anode to the cathode, right? So this is basically, I have positive ray. Wait, I'm gonna make this with red color. So for instance, this is positive ray. Here we have two, here we have two, right? Positive ray, positive ray, and of course this is positive ray. When they strike to the wall of it, they get glow, and the glow is green, right? This glow is green. So basically, what should I write here? They produce, wait, let me highlight this. They produce fluorescence, fluorescence when strike with zinc sulfide, right? Zinc sulfide, which is written as capital Z N and capital S, right? Zinc sulfide. So these were the properties of cathode rays. In the next video, we're gonna discuss about the discovery of neutron.